everyone knows what gravity is. You know that if you take a big heavy object like the sun or our Earth, it will attract with gravitational forces any other object that is close to it. So the Earth will attract the apple, it will fall to the ground. At the same time, the moon is kept in its orbit around the Earth, also by virtue of the gravitational forces that the Earth exerts on it. Now, what is a black hole? Imagine you take our big, massive Earth and you compress it down to a tiny, tiny, tiny object, not bigger than a pea. This is now so heavy that the gravitational forces it exerts are so strong that not even a light ray can escape from it. It will get trapped. That is a black hole. What does it mean when we see something? It means that light from a bright object, say a distant star, reaches our eye. That's when we see something. Now, imagine a light ray from a very distant star passes by a black hole. What happens? Nothing very much. The light ray gets bent a little and it reaches our eye and we can see the distant star. Now, what happens when the light ray passes much closer to the black hole? It will enter the black hole horizon, and that is exactly the region from where it cannot ever escape anymore. It's trapped by the black hole and will end up in its center. What do we see? Nothing. The black hole has swallowed up the light ray. It cannot reach us anymore. All we see is black, nothing. That's why it's called a black hole. Black holes are certainly not dangerous for us humans at all. We know currently of two types of black holes. Stellar black holes, of the size of our sun. As they collapse, they can form black holes. And there are black holes at the centers of galaxies, like our own Milky Way. Now, it is true that if you came close to a stellar black hole, it would be very unpleasant. There were very, very strong forces, and your body would be pulled and pushed apart. However, you really needn't worry. These black holes are very, very far away. We cannot feel their forces at all. They're so far away that we could never travel there in our lifetimes, nor are they able to come here. We theoretical physicists are so excited about black holes because we believe they could provide the key to something we do not yet understand, and that is a theory of quantum gravity. Black holes are described by Einstein's theory of general relativity, which is 100 years old. But this theory cannot give answers to all the questions we can ask about black holes. An important question is, what happens when something falls into a black hole? What happens at the very center of the black hole? Einstein's theory just says the forces and the energies are infinite. That's not a sensible physical answer. We know that in order to get a good physical answer, we must take quantum effects into account. Now, a theory of quantum gravity, which would do that, is a crucial missing piece in a theory of everything that everyone has been looking for the last 30 years.